Hello, everybody. So today we're going to take a look at caching, how to implement that with Spring, what it brings to the table, and what pitfalls we might encounter along the way. But without further ado, let's dive in. So let's now take a look into our application. We have a very simple console application here with the awesome method do caching stuff. This will call a method call on me with a key here 2 times, and then it will also call a method which is called get foo. If we take a look how this is implemented, this is just the standard Spring Bean, which has this method call on me, which has an ID, and it will return a new object, which is just called call. And we have the method getFoo that will return a new foo object. How can we implement caching? We have multiple options. One of the easiest options is to go with Caffeine. Caffeine is a so-called in-memory caching manager, so it's just in memory. We need two dependencies here for Cradle, this one and also the Springboard starter cache. We have this here. And then let's go step by step what we need. So we need add configuration, add enable caching. There are also some hints here that we might need for reflection if you want to build a native image. And then we need to implement this interface, which is called caching configurer from Spring. We then need a bean which is called cache manager, where we can have some configuration. So basically, we can set an expiry here to 10 minutes. So we do not want that our cache grows without endlessly. So we can say after 10 minutes, the cache will be removed. So what's in the cache will be removed. That's also important because if you don't remove things from the cache, and consider you put something in the cache today and you will do a call tomorrow, then you will get the old state from yesterday. So this is why we have expiry that's set to 10 minutes. So after 10 minutes, this will be removed. And there is also a cache max size so that no more than 1000 items can be in the cache. What's also important is this thing here, that's the so-called key generator. This is optional, but if we don't have a key generator, we will run into a lot of problems. We will see that later. So basically, the key generator, as the name suggests, just generates the key for the cache. And the key consists of a method name, the parameters for the method, also a so-called tenant ID. So if we are in multi-tenant environment, we also need the tenant ID here. And if we have additional discriminators, for example, this thing which is called organization ID, we also have to put this here. If we don't put the tenant ID here, this means that multiple customers would see the states of other customers, because if we should consider that caching is something that means that we get a stateful application. But with that being said, we can now try our application. So I will run this. The call on me method should get called 2 times. We see here cache missed inside call on me. So we get in here first time, it will return the call with the ID 0. And then the second time I'll be calling it, it will still call the method and say cache missed. If we now just put our add cacheable annotation here, we should see that the method only gets called once. So let's start again. And we see here 1 time cache missed, but it will return 2 times the result. So what happens in the background is if we have the add cacheable annotation at our test component, the second time that Spring will try to call the method, it will take a look into the cache depending on our cache configuration. And it will decide, okay, the result is already in the cache depending on the key we provided. So I can do a lookup from the cache. That's all very nice, but as I already said, we have to take good care of this guy here. So for multi-tenancy, we really need to put the tenant ID here, but we can also see, even without multi-tenancy, what will happen if I simply remove the key generator. Remember, we call the method call on me and the method get foo, and the method these methods basically have the same signature. They just get passed in a string. And if you don't provide a key generator, it will just generate the keys based on the signatures here. And then for Spring, this method and this method looks the same. And what will happen, there is an annotation here, is the following. We get a class cast exception. So why is that? Because the first method gets called, there is something put into the cache, and then the second method gets called, and then it starts to mix up the call object and the foo object. And that's a problem because now when we call the get foo, it will instead return the call object from the cache. So this is also why it's important to have a key generator here. Let's revert it, key generator back, like this, run it again, and then we should be safe and sound. This is, of course, only a problem if you are in a component that returns different types. If it's always the same type, like it's always a person or it's always an address, this will not happen. But I think it's a best practice to have a key generator configured like this with the method name, the params, and then also the tenant ID, so you do not run into trouble. This is all very nice, and that's a simple way to get a cache. Remember, it's an in-memory cache, but there is a small disadvantage here. So if we run the application, oh, I have to clean my Cradle cache. So if I run the application here, we will see we get the cache missed because it will only get the thing the second time from the cache. If we have a simple environment, so nothing like Kubernetes, where we have multiple instances of application deployed, and we only have one instance of our application deployed, that's not a big problem, because if we only have one instance, we have the cache inside our own instance and it will work. But if we have multiple instances of our application deployed, the problem is, and this is something we can simulate just by calling the application a second time, and again, I have to clean, and just consider this being the second instant. The second instant will also not have a cache because the second instant does not know about the cache about the first instance. And this is something where we need something else, where Caffeine cannot help us, and this is something we will now take a look into. So what can we do now if we have replication in Kubernetes? We obviously need something that can hold our cache for all applications, for all instances. And this is where Redis comes in. Redis is a simple in-memory database that can hold the caching state for all our replicas here. So we can just say docker run, start the Redis database, and it will bootstrap. The nice thing is also at its initial state, it doesn't use a lot of RAM. So we see here it consumes only 20 megabytes of RAM. It can even go lower as only 8 megabytes of RAM. So now we have Redis in place. Then what we also need is, of course, we cannot use Caffeine now. So we have a Redis caching configuration, which is similar to the Caffeine one. We can have the expiry here. We have a key generator here, which is similar to the other one. And what's also important is now, unfortunately, that we have to register all our objects that we want to put in the cache. So the foo and the call object, we need to have this register for reflection here. I have it in another class, so because of this, it's commented out. But now let's see what will change. So I will start my application again. And we see, again, cached missed inside call on me. So first call is a cache miss, second call is a cache hit. But now what changes? The second time I start my application, and again, I have to clean. The second time I start my application is, you see, we don't get a cache miss here. So even the second time my application is started, and you can consider this to being the replicas, it will just get the state from the Redis cache. And with that being done, we now have the opportunity to have, with a replication state in Kubernetes, to have a solution here. But as always, there is a drawback. So there is no final solution. So what's the drawback? If we use Caffeine, we just have it in memory. That is very fast. If we are now using something like Redis, which is basically just another database, we need to do a remote call to this database. So there is additional time consumed here. And the lesson here is we should only do that if the call to the thing we cache, for example, the database, takes much longer than the call we need to do to the in-memory database. Usually Redis is very fast, but please keep this in mind. That's basically it for today's video. Thank you so much for joining me, and I hope to see you in the next one. Bye.